25 minutes to 10 o'clock, and it's 0214460567 or 011-883-0702 if you want to talk to Chris, our naked scientist. Good morning to you, Chris.
Hey, good morning.
Thank you so much for joining us. We just had some problems with the lines, but I'm so glad we connected. Any developments on the fight against Ebola? The news is sounding very, very somber.
Quite bleak, isn't it? There's some good news and some bad news. The bad news is that just in this week gone by, we've seen the WHO announce another 700 cases of Ebola. So the death toll now is well on the way to 3,000 people, with more than 5,000 people infected and affected. So very, very high numbers, at least 10 to 20 times bigger than any previous outbreak we've seen. There's not really very much good news in terms of the spread. The WHO have published a situation report where they're identifying a number of factors as to why they say this is happening, why it's intensifying. There's an interesting series of points. I'm just looking at the website, and they say that they've currently invested something like $56.9 million in this problem, but this is, I think, too little too late. They say that the current issues are that there are few beds in few hospitals with too few staff. So in other words, there's just not the medical capacity to cope with this. There's a lot of healthcare workers who have been affected and also died. 302 healthcare workers, 152 dead so far. And those are the ones we know about. So they've now got problems with people who are just not turning up to work because they're terrified. There's also, they say, quite poor community buy-in. In other words, you've got a situation where the infection control practices which could stop the spread are not being implemented properly because local people don't trust, don't wish to work with, or choosing to reject the advice of healthcare providers, people coming in from overseas, advisors and so on. And there's also a sort of civil breakdown going on in some of these places where you've got people just taking matters into their own hands. We've heard reports of people busting into hospitals and breaking out isolated Ebola cases and taking them back to their villages. And then, of course, they spread the disease. Then there's the poor bunch of people who've survived Ebola. They're no longer infectious. They're actually immune. And they're facing being rebuffed and rejected by their community because people don't want to catch it from them, even though they couldn't. So a really big problem. There's some good news, though, which is that just in the last week, we've had an announcement from the University of Oxford in England. They've just started administering a test vaccine, which is being made in collaboration with GlaxoSmithKline to a cohort of human volunteers. The way it works is that they've got a chimp cold virus called an adenovirus, which has been disabled so it can't grow, but it can act as a sort of vector. And they've put into this virus a piece of genetic material that encodes the coat of Ebola so that the cold virus will make the body see this particular structure, which is normally present on Ebola, and this will make the body make antibodies. And once you've got antibodies, if you're challenged by Ebola for real, you should be able to soak it up and stop it. So those trials have been very effective in chimps. They're now starting these safety trials in healthy human volunteers to see if that will work out. There's another company, Newlink, in the States, who've also got their own form of this vaccine. It works with a slightly different virus as a vector, but it's a similar sort of strategy. The downside to this, they're all saying that they don't have the capacity to scale this up fast enough. They need thousands and thousands of doses. And one spokesman for GlaxoSmithKline said, at our present trajectory, it's going to take us a year and a half to make enough vaccine to stop this thing. And we've got predictions that we may reach 20,000 cases if this continues to go the way it is. So it's certainly a worrying time.
It is indeed, and especially the beliefs also in villages. We heard in our Africa report just a few hours ago that 3 journalists and doctors, their bodies had been found, they'd gone missing. People were attacking them because of the information misinformation really, the beliefs that they hold about Ebola. And these 6 guys, the journalists and the doctors, were really trying to make a difference in that particular village, and they were killed. Very disturbing indeed. Let's go straight to the lines. Is it Isla? Isla is 14 years old and calling us from Somerset West. Good morning.
Hi.
You have a question about Ebola, right?
Yes.
Yes. Carry on, please.
How come they say one of the causes is that they're eating bushmeat, but how come the people in the Amazon are eating bushmeat and they're not getting it?
Hello, Isla. The reason for this is that Ebola only lives in a very limited number of places on Earth, or at least the strains of Ebola that we've discovered so far are only present in a very limited set of geographies. There are 5 known types of Ebola, and 4 of them are found on the African continent. One of them is known to exist in the Philippines. The one in the Philippines only infects animals, it doesn't really infect humans. The ones in Africa have all at some time infected humans. Some of them have infected more humans than others. So although people may eat bushmeat in other countries, if the local animals in those other countries and other continents don't have Ebola in them, it can't spread into the people. Whereas in African countries that carry or are host to Ebola, the most likely animal that's carrying it is things like bats, small mammals, fruit bats. And when those fruit bats get either trapped by people, caught and eaten, or there's a drought and the animals get together around the limited water and food supplies that there are, then the virus can spread from the bat into other animals as well. And then when people catch those animals that are incubating Ebola, they can catch it too. And in the present outbreak, people have looked at the genetic material from the virus that's infecting these people, and as far as we can tell, the Ebola jumped out of an animal once into one human, and all of the rest of the cases have been human-to-human spread. But a very good question. Thank you for that.
Thank you, Isla. Thank you. Let's go to Kisho. Kisho in Saverwood. Good morning.
Good morning to all.
Mm-hmm.
I'd like to just find out, parents have, children come from the same parents. And I just want to know, why are the children not looking the same when children are born like years apart? What contributes the children to look different? And I'll actually listen to the radio.
The beauty of genetics means that of the 7.2 billion people on Earth, almost all of us are genetically unique. Why only almost all of us? Because some people are natural clones called twins, and this is where the embryo has divided or split into 2 during development, giving rise to 2 genetically identical individuals. But in all other respects, as far as we can tell, everybody on Earth is genetically distinct. How is this achieved? Well, when we go through the production of sperm or eggs in the body, if you're a woman, the ovary contains eggs. If you're a man, the testes make sperm. This is a special form of cell division called meiosis. And meiosis is where you start with a cell and you take all of the chromosomes which are in the cell and you initially double them up, you copy them all, and then what you do is you divide them in half between the 2 daughter cells, and then you do that again. So you end up with a set of daughter cells that contain just 1 of each of the 23 pairs of chromosomes that an adult mature human would do. And that automatically means that of the 2 sets of chromosomes you have in each of your cells, in each of the sperms that you pass on or the eggs you pass on, you've only got 1 of those, and you're going to mix it with an entirely new copy of that chromosome from your partner. So there's already genetic diversity creeping in there. And every time you go through this process, each of the chromosomes is sorted individually. It's not the same 1, 2, 3, 4, 5 that go into one sperm and 1, 2, 3, 4, 5 that go into the other sperm. It's a random choice of which of the pair go in. So that mixes things up. And then there's a further mixing phenomenon called crossing over. And when you go through the first of these phases of division, where you double up the chromosomes and then split them apart, the homologous, in other words, the matching pairs of chromosomes, so your chromosome number 1 from your dad and your chromosome number 1 from your mother, they line up next to each other, and then they swap bits of genetic material between themselves. And they swap the analogous region. So if you've got an area which, for instance, codes for your hair colour, the chromosome you got from your dad would swap that region with the chromosome equivalent from your mother. So now you end up with a chromosome which has got actually bits of your mum's chromosome in it, and then you pass that one on. So this further mixes up the combinations of genes on the chromosomes. So in other words, you've got a situation where the individual chromosomes mix up their genetic material, and you then mix up which chromosomes you pass on into your sperms and eggs, so that when you end up with one sperm meeting one egg and mixing the 23 chromosomes it's got with the 23 chromosomes in the other to get 23 pairs of chromosomes, what you need to make a human again, you've got a completely unique combination of genes, And that means that because the genes are the recipe book from which your body is made, you get a unique body.
Thank you very much, Kishore. Let's take a break. And Mark, Steve, John, I see your calls. We'll be with you in just a moment. And we are with the Naked Scientist, and we're taking your calls, your questions, which, we always welcome on SMS and Twitter. I'll read some in a moment. But Steve in Paru, good morning.
Good morning. Hi. Well, I saw on CNN that China wants to mine helium-3 on the moon for what they called clean nuclear energy using fusion. I just wondered what Chris thought of it. Apparently they're sending people up there in 2016.
Hello, Steve. Well,
hi.
it's certainly true that the moon does have deposits potentially of helium-3 on it, but that's about as far as the certainty goes. Why am I sceptical? The reason is that whilst, yes, you could recover this helium, you've then got to have a fusion process to put it into on Earth, which is capable of being used usefully. And at the moment, we haven't cracked the nuclear power problem relating to fusion. We know it works. We know the physics of fusion very, very well. You just have to look up in the sky and you'll see the biggest nuclear reactor that you're ever going to see in your life in the form of the sun, bathing the Earth in energy from fusion. But trying to recreate the sun on the Earth's surface is a tall order, and scientists haven't cracked it yet. But yes, people are interested in the idea that perhaps we could mine the moon, not just for helium-3, there may be other things there as well, but certainly there are known to be deposits of helium that could be recovered, and the moon is one possible source. But at the moment, sending a space rocket there, sending the infrastructure there, sending the mining equipment there to get it, and then getting it back to Earth seems like an impossible challenge, or at least one which is not energetically favourable. The amount of energy you'd burn off doing all that would way outweigh the amount of energy you got back and pollution you saved by recovering the helium to the Earth. So it might be that perhaps you'd make the energy up there and then find a clever way to beam it back. But certainly it's all speculation at this stage.
Let's go to, is it John in Randburg? Hi.
Hi, good morning, Chris. My question is, I'd like to know why we're told not to refreeze meat. I've taken meat out of the freezer, defrosted it. It hasn't gone off or got warm. It's still cool. Refrozen it, and it's been fine. And yet most of the packaging actually says do not refreeze. What is the reason for that?
Yeah, the reason for this is that the more time that a foodstuff spends at a higher temperature, the more likelihood there is that microorganisms could grow on the foodstuff and then produce toxins or other chemicals that could, even if you cooked the meat very thoroughly and destroyed the microorganisms, the toxins may not be sensitive to heat. They may stay there, and then when you consume the meat, they can make you unwell. And there are lots of bugs that can do this. Staphylococcus aureus, that lives on very many of us, on the skin, is capable of making a toxin, which is a secreted chemical, and when the bug grows on something, it just secretes this chemical into the environment. When you then put the food into the oven and heat it back up to a high temperature, the staphylococcus is destroyed, but the toxin isn't. And when you eat the food, the toxin then damages the cells in your intestine, and it causes you to become violently ill very promptly and for a very short time. And then you feel completely well again. So what people say is when you've got foodstuffs, keep them cold, keep them below the temperature at which microbes will tend to grow, and some microbes are still capable of growing in a fridge, but if you freeze meat, then that should arrest the biochemistry and stop pretty much anything growing. But as soon as you raise the food above that temperature, if it sits there for a while, if it has been contaminated with microbes don't mind being frozen for a while. They'll come back to life from the freezer, they'll then grow for a while, and they could contaminate the food. So if you then freeze it again, you're freezing the meat plus the toxins. You then cook it, and yes, it tastes delicious because these toxins have no flavour, but they sure as hell can make you feel pretty awful later. So it's better to look at these sort of food standards and try and observe them, because they're there to try and keep you safe.
Yeah, and protect you. Thank you very much, John, for that question. I think a lot of us have learned and could use that information. There's an SMS here. Chris, what is the scientific explanation for birthmarks, and does everybody have a birthmark?
No, not everyone does. A birthmark is a patch of pigmentation on the skin or depigmentation on the skin, and it's usually randomly positioned on the body surface, but in some people there's a mark in a similar sort of place between parents and children and between two children. And this is because when you're developing as an embryo, your body starts off as a flat plate of cells, and this flat plate of cells then rolls up into a tube resembling the sort of cardboard tube that you'd find on the inside of your loo roll or your kitchen roll, for example. And then inside that tube, a nervous system grows and a gut grows, and the skin is around the outside. And the nervous system is or sends signals to the overlying skin and tells each segment of the body what to become. And it induces a pattern of genes to be turned on or off there, which is how different parts of your body know that this area I'm going to make a pair of arms, this area I'm going to have my belly button, my breasts, further down I'm going to have my legs, and so on. So there's this segmentation of the embryo with expression of certain genes in the overlying skin, which is how the body also knows to put hairiness on some bits of the body and non-hairiness on other bits of the body. Mm-hmm. And therefore you can also trigger the expression of certain pigmentation genes. And this is why you might have, say, the back of the hand might be more darkly pigmented than the palm, same with the sole of the foot, because there are genes controlling what other genes are turned on in other daughter cells in those areas. So you can, if you've got a certain pattern of genes turned on in your family in a certain way, it's possible that certain birthmarks could end up expressed in the same sorts of places in families. But on the whole, it's pretty much random, and it reflects just cells being a bit more active, making a bit more pigment or a bit less pigment in certain patches on the body.
Let's go to Mark in Durbanville. Hi.
Morning, really. Morning, Chris. Chris, I was recently reading a magazine article written by a pilot who used to fly SR-71s during the Cold War, better known as the Blackbird. And he was saying that when they used to fly over the USSR, they were often shot at by SA-2 missiles or surface-to-air missiles. But due to the curve of pursuit, they were unable to intercept the aircraft. And I'm trying to understand what is meant by the curve of pursuit.
The curve of the shoot.
The curve of pursuit.
Oh, right. I can only think that they weren't terribly good at predicting the trajectory of the aircraft. There's a number of aspects to this. There's quite a famous experiment, in fact, that was done a long time ago, which is sort of analogous to this, called the monkey and the hunter experiment. And this is to show you the effect of gravity. And you can do this experiment in your school classroom, because what you do is you have a tin can stuck onto an electromagnet, and it's on one side of the classroom, and you have a ball bearing in a tube on the other side of the classroom, and in front of the tube the ball bearing's going to come out of is a strip of foil, and that's completing a circuit to the electromagnet holding the tin. And when you shoot the ball bearing out of the tube, it breaks the foil and therefore breaks the circuit to the electromagnet, which causes the tin to begin to fall. Now, the ball bearing comes out of the tube going straight on, but by the time it reaches the tin can on the other side of the room, the tin can has fallen a considerable distance towards the floor, but the ball bearing still hits it. Why? Because gravity is acting on both and pulling them down, so that you end up with a curve of pursuit whereby the ball bearing hits the tin. In other words, if you were firing a gun, you've got to anticipate where the object is going to be after the time that you pull the trigger, and between that time and the bullet hitting the object, hopefully, where the two are going to meet. So if they get it wrong and you fire off your missile and you press the button and you don't aim far enough ahead, anticipating where the craft is going to be in the future, then you're not going to intercept it. And I think those craft were incredibly fast, weren't they? So if they weren't capable of getting the missile to go sufficiently far in advance and ahead of where the aircraft was going, then there's no way that they could actually catch them. And also I think that they could, if they knew they were being shot at, all you have to do is fly a bit faster for a while, and then all of their targeting would go out of the window if they weren't actually actively pursuing the aircraft with kind of guided missiles. So I think that's probably the answer. But if anyone is in munitions and knows better, please do tell me.
Chris, I can't resist this. An SMS, somebody says he was born already circumcised. Is that normal?
Well, the process of circumcision is where you are actually physically removing the foreskin. But some people are born with a penis that looks like it's been circumcised, but they're not obviously circumcised. It's just that they have a small foreskin. And this can happen. It's not that common, but it can happen. And what tends to happen, or what tends to be the case, is that when people are first born, usually the skin is there, but it might be a little bit small. But as you grow up and things get bigger down there, then everything outgrows the amount of skin that's available to cover it up. And so you end up with the end of the penis being disclosed anyway, saving them the bother of having to get circumcised, I suppose. It's certainly, I think, probably it's not a disadvantage to be like that. It may even be cleaner.
All right, Chris, we'll chat again next week then. Thank you.
It's a pleasure. Thanks, everyone.
Bye-bye,
See you soon.
Bye-bye. And we will podcast this conversation with the naked scientist. We've been doing this feature for many years now. I think, 5 years? I can't believe that there's still people who send in SMS. Is the naked scientist really naked? Is the naked scientist clothed? Every single week, those SMSs are still coming. Cute, man. You can imagine it started on the first day when we said naked scientist. Huh? Does he have clothes on? And it's still 5 years later coming through the SMS line. We will have this as a podcast for you.